So, hello, dear students. Today we will solve one more problem. This problem is basically from optics class 12th board problem. This problem was asked in 2004. The problem is like this. In this figure, the figure is given. ABCD is a ray of light passing through an equilateral glass prism EFG. You can see this EFG is a glass prism and suffering minimum deviation. So here the light is suffering minimum deviation. And this problem, they are asking calculate the angle of refraction at B and the angle EBC. And the refractive index of glass is given, that is 1.5. So students, this is a very simple problem. We'll proceed for the solution. So here students, we have to calculate the angle of refraction at B. So here, as we all know that there is some relationship between angle of prism and angle of refraction and the angle of incidence at the second surface. The relationship is like this. But before, we have to mention some angles here in this figure. Here R dash is the angle of incidence at the second surface, that is EG of the prism, and here this E is the angle of emergence, and this is this dotted line. As you can see, this is a normal, and angle of this incidence, that is R dash at the some second surface. Actually, we define all these angles with respect to normal. So students, so as we all know that there is one relationship between angle of prism and angle of refraction at the first surface and angle of incidence at the second surface, and it is A is equal to R1 plus R2. So here in our case, R1 is R plus R2, R2 is R dash, and students, for minimum deviation, for minimum deviation, R is equal to R dash. Uh, Actually, this is given in your book also, but here I'm explaining it. Students, ABCD is the path of ray of light. And students, if you reverse the path of this light, and if it becomes DCBA, here हम लाइट का जो पाथ है उसको रिवर्स कर रहे हैं अकॉर्डिंग टू प्रिंसिपल ऑफ रिवर्सिबिलिटी ऑफ लाइट. तो लाइट रे का पाथ क्या हो जाएगा? दैट विल बी DCBA. अब इस केस में देखो, एंगल ऑफ इंसिडेंस क्या हो जाएगा? E हो जाएगा. एंगल ऑफ रिफ्रैक्शन क्या हो जाएगा? R डैश हो जाएगा. एंगल ऑफ इंसिडेंस R एट द सरफेस EF, it will be R. And here, तो हियर लाइट रे इंसिडेंट हो रही है एट सम एंगल आई. तो हम यहाँ अब अगर हम इस डायरेक्शन देखेंगे ABCD, तो क्या आई यहाँ पे क्या है? इट इज एंगल ऑफ इंसिडेंस. बट स्टूडेंट्स, अगर हम लाइट रे का पाथ रिवर्स कर दे तो एंगल ऑफ इंसिडेंस क्या हो जाएगा? फिर E हो जाएगा. एंगल ऑफ रिफ्रैक्शन विल बी R डैश, एंड हियर एंगल ऑफ इंसिडेंस एट द सरफेस EF विल बी R. सो स्टूडेंट्स, अगर हम लाइट रे का पाथ ABCD लें तो यहाँ पे क्या होगा? अगर हम यहाँ पे स्नेल्स लॉ अप्लाई करते हैं, if we will apply Snell's law at point B, then what it will become? Just see. Snell's law is N1 into sine I is equal to N2 into sine R. Students, here light ray is going from air to glass. So here refractive index of air is 1. 1 into sine I is equal to 1.5 into sine R. And students, here 1.5 is equal to sine I upon sine R. It is equation number 1. And students, here we will apply Snell's law at point C. So here if you will apply Snell's law at point C, then here N1 into sine I, here angle of incidence is R dash, is equal to N2 into sine of angle of emergence. Here light ray is going from glass to air. So here it will become 1.5 into sine R dash is equal to 1 into sine of angle of emergence. And here students, if you will simplify this, it will become 1.5 is equal to sine of angle of emergence upon sine of angle of R dash, sine R dash. Let it be equation number second. And students, here angle of deviation is equal to I plus I dash minus A. And students, as we all know that for one, only one particular angle of incidence, the prism produces minimum deviation. So here, and the minimum angle of deviation is represented by delta M, as you all know this notation. I hope you all are familiar with this notation. Here delta M is the angle for minimum deviation. And students, and this deviation is minimum for only one particular angle of incidence. Uh, Suppose that at particular angle of incidence, that is I, your angle of deviation is minimum. And here in the problem also it is given. Uh, Here the light ray is suffering minimum deviation, and let's say it is I. It is the only one particular angle of incidence for which this light ray is suffering minimum deviation. And students, here, if you will reverse the path of ray of light, suppose that light ray is going like this DCBA, then here, students, angle of incidence will become E, angle of refraction will be R dash, angle of incidence at the surface EF will be R, and here, students, angle of emergence will be I. So here again, the light ray here is suffering minimum deviation at angle of incidence, that is E. So students, here delta is minimum for two angles of incidence, for two angles of incidence I and E. So students, but according to uh, our theory, delta can be minimum. Delta can be minimum for only one, for only one angle of incidence, angle of incidence. So here I will be equal to E. So students, here from equation first and second, here I am writing the both equations together. Here 1.5 is equal to sine I upon sine, here it is R, which is equal to sine E upon sine R dash. So here students, if I is equal to E, then R will also be equal to R dash. So students, so we have proved this, that our delta is minimum for this angle, that is R is equal to R dash. So here students, A is equal to R plus R dash. So here if R is equal to R dash, so students, our A will become equal to 2R and R will be equal to A by 2. So here our R will become 60 degree by 2, which is equal to 30 degree. So here we have calculated our angle of refraction and it is coming out to be 30 degree. And here we have calculated this angle of refraction at B. So here it is 30 degree. So students, and here we have to calculate the angle EBC. And students, if you will carefully see this angle EB and this dotted line, it is exactly 90 degree. And students, here angle EBC, it will be equal to 90 degree minus R. Here our angle EBC will become 90 degree minus 30 degree. Then our angle EBC, it will come out to be 60 degree. We have calculated this angle also. So this was the solution of this problem. And we will see one more problem. Let me upload that problem. Students, this is a long answer. It is passage based problem. And the students will proceed for this problem. The problem is like this. If you will see the problem, a prism is a wedge-shaped portion of a transparent refracting medium bounded by two or three plane surfaces inclined to each other at certain angles. You can just see I, R1, R2, E. And in a prism, sum of angle of incidence and the angle of emergence, E is equal to sum of angle of deviation and the angle of prism A. And students, as I increases, delta first decreases, reaches a minimum value, that is delta min, angle of minimum deviation, and then decreases. Delta min is called the angle of minimum deviation. At minimum deviation, ray passes symmetrically through the prism. As you can see, the light ray is passing symmetrically through the prism. And in first part, students, they are asking what is the relation among angles R1, R2, and A? So, dear students, we'll proceed for step by step solution. So, here in first part, they are asking what is the relation among angles R1, R2, and A. So, students, you all know this famous relation, that is A is equal to R1 plus R2. We have proved this in previous solution also. So this is the solution of first. And for second, if E is equal to Ki, then what will with the value of K when incidence ray suffers minimum deviation as it emerges out of the prism? So students, for second part, at minimum deviation, at minimum deviation, deviation, E is equal to I, and students, here if you will see, they are asking E is equal to, then what will the value of K? So here the value of K will be equal to 1, because in the question it is given E is equal to Ki, and for minimum deviation K is equal to 1. So here it will become E is equal to I. And students, in the third part, suppose the prism is a regular prism and incident ray suffers minimum deviation as it comes out of the prism, then what will be the angle between refracted ray inside the prism and the base BC of the prism? So students, if the light ray suffers minimum deviation, then students, what happened? This, the refracted ray inside the prism, it is always parallel to the base BC of the prism. So here students, they are asking for the angle. What will be the angle between refracted ray inside the prism and the base BC of the prism? So students, it will be 0 degree. As you can see, this is parallel to base BC of the prism. So the angle will be equal to 0 degree. So here the angle is 0 degree. Next part. In fourth part, students, they are asking, figure shows the graph of angle of deviation delta versus angle of incidence I for a light ray striking a prism. You have to calculate the value of the prism angle A. So students, here fourth part, as we all know that delta is equal to I plus E minus A. And students, if you will see this, the delta is here 30 degree, and students, here angle of incidence is 15 degree, and here angle of emergence is 60 degree. As you can see from this graph, this is 60 degrees the angle of emergence, here 15 degree is the angle of incidence, and delta is 30 degree. And students, we will keep these values in our formula. So here it will become 30 degree is equal to 15 degree plus 60 degree minus A. And students, if you will simplify this, it will come out to be 45 degree. So here we have got our angle of prism as 45 degree. And if you will see, we'll proceed for fifth part. Write the expression for the minimum angle of deviation delta m for a thin prism in terms of refractive index of the material n of the prism and the prism angle A. So students, the relationship is as you all know that the relationship is delta m is equal to n minus 1 into A, where n is refractive index and A is angle of prism. So this was the solution from my side. If you like my problem solving technique, then you can like, share, and subscribe my YouTube channel. That's all. Thank you.